Okay, nice to see you all. How are you?
We are great, sir. How are you?
Good, good. Nice to see you all. So, to start with that, okay, to start with that, so are you able to follow the all the lectures which has been given from NPTEL? Uh, is it easy to follow, or is it what's your general feeling about it? Then I'll come back to your questions. I
Sir,
can't able to. Yeah, one by one, you can just open up. Yes.
yes, sir. So my name is Salil Tiwari,
Yeah.
and I am from Pondicherry University. And
Mm-hmm.
I found the lectures quite easy to follow,
Hmm.
and the curriculum is very well designed. So from the basics, we are able to understand. So I found it really well, sir.
Good. You are a master student, or
Yes, sir. I am a student of Masters Bioinformatics first year.
nice, nice, nice. Anybody?
Good evening, sir. Sir,
Good
I
evening.
am Jeena. I
Nice,
am
nice to meet
pursuing
you.
PhD in genetics, but my PG is anatomy. So I have no base in biochemistry or chemistry. So at the beginning there was a starting trouble. Now it's okay.
Okay, good. So you are from?
I am from Kerala.
Okay, which university?
PhD in Maher University, Meenakshi Academy of Higher Education, Chennai.
Oh, okay, okay. Magar University. Okay, good, 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 good. Right. So, any other any other?
I have some doubts in between, like base flipping, Yamaka factors. All
Right.
this I didn't get.
I'll come to that. The specific question I'll come. So I want to have a
Okay, sir.
general opinion from others. Or maybe you can introduce
Okay.
yourself.
Thank you, sir.
Only we had 10 members are joined. So maybe Arshavardhan, can you please introduce?
Sure, sir. I'm a third year bio undergrad from Central University of Chhattisgarh, and that I really enjoy our courses and find the material engaging.
Right, right, nice. So, by the way, Mr. You are from?
So what?
No, you are from which university?
Can I'm from the Guru Ghasidas University, Chhattisgarh.
Okay, okay, yeah. In this, the voice breaks, so I couldn't able to follow it up. Good, very good.
Sorry. Thank you,
Irfana
sir.
KP.
Hello, sir.
Hi.
I am Irfana and I'm currently pursuing my master's in zoology from Central University of Kerala. And the classes are going good. At the initial at the starting phase, I was in an internship. So now I'm just catching up with the classes. Yeah.
Okay.
Okay.
there was some net connection error.
Okay, sir.
Yeah, maybe let me get introduction from others as well. Saumana.
Good evening, sir.
Good evening. Yes.
I am currently pursuing an integrated master's course in biotechnology in St. Xavier's College, Kolkata. And in a second year only, I got a brief introduction about DNA methylation and all of that while learning DNA damage repair. And that piqued my interest. And so I wanted to pursue this course on epigenetics. And it's quite helpful. I'm enjoying the course so far.
Very good. Very good. We'll come back. Siva Pranav, are you able to connect?
Hello, sir. Good evening, sir.
Hi. Good evening. Good evening.
I'm a B.Pharm graduate from Manipal College of
Nice.
Pharmaceutical Sciences.
Hmm.
And I'll be joining Kyoto University as a research student from this October.
Very nice. Good. Tripti?
Yeah.
Tripti, are you available?
Am I audible, sir?
Yes, now, yes.
Myself, Tripti, and I'm currently pursuing Masters in Zoology at Mumbai University. And I'm actually finding the overall course quite helpful, but my pace is little slow from you. I have all the lectures and all. That's why I'm not able to follow the pace that like the what would we say that the pace I'm
Okay.
not able to follow, but I'm learning from the course
Right.
quite in a
Right.
good manner. Thank you,
Okay.
sir.
Okay. Very good. Okay. Okay. So once again, thanks for joining. And then now we can go to specific questions. So far, what you covered, I mean, what you learned or what the lectures you learned. One by one, we can go. Please, ask your questions. Like Gina, you had some questions, right? What was that?
Sir, I have a doubt. Sir, in the first assignment, there was a base flipping.
Right.
In that, the correct answer was type string flipping. What is the difference between base flipping and type string flipping? It was a question in assignment.
Yeah, the correct answer is base flipping only.
But I have written base flipping, but my answer was incorrect. The correct answer was type string. It is in bracket flipping.
Okay. So there was that program allowed to put only one word. Okay, I given to them to join as a base flipping. And then they typed a base separate as a word and then flipping separately as a word. So that is why finally they could able to accommodate only flipping, because that the program such a way only one word can be kept as an answer, not two words. So although I given as a joint base flipping, but they kind of separated, and then that is why it became an error. But those who were given the base flipping also right, flipping also right. But anyway, I tell this, this I informed to them, because I think the answers, some of the comments I got it up. I will try to, I'll ask them to consider those written as a base flipping or flipping.
Okay, thank you, sir. Then another one, Yamanaka factors.
Yamanaka factors.
Yes, sir. Yamanaka factors.
Yes. So this is also from assignment, or what is the question here? No, what is the question here?
Yamanaka factors, it was in the first week lectures.
Okay.
I think so.
Are you asking, this is part of assignments or from the lecture?
From the lectures, from week 2, introduction to epigenetic players.
Okay, so still you will when you come to the stem cell epigenetic classes, you will understand about this much better actually. So
Okay,
this
sir.
is nothing but it's a transcription factors. Okay,
Okay,
transcription
okay, thank you, sir.
factors are reported by the Nobel laureate winner Shinkai Yamanaka,
Okay, sir. Okay, sir.
from Japanese scientists who shared the Nobel Prize along with Gordon for the discovery of the
Okay,
generations.
okay,
So,
okay. Sir,
it is
my topic is
essential.
transcription factor Hoxagen gene.
So
Hoxagen
the
gene transcription. Any connection with it, sir?
since
Hoxagen, it is a
transcription factor.
gene coming in implantation failure. This is a
All right,
gynec
right.
topic.
Yeah, so what the Yamanaka factor means, this is referring to the 4 major transcription factors that we used to convert the differentiated cell back to the pluripotent system cell. So
Okay, sir.
that is why the name was commonly used. Otherwise, you have to mention all the transcription factor, OCT4, NANONG, SOX2, KLF, and so on.
Okay, thank you, sir.
Okay, you will have a better idea when you will be listening there. I have a separate chapter on the stem cell epigenetics, which is coming up later. That these
Okay,
ideas
sir.
will be
In anatomy, I have studied embryology. In that, it comes like the development course from the zygote to each step, morula,
right.
blastula, morula,
Right.
implantation. In that way, it's easy for me. Now,
All
biochemistry,
right.
I didn't study it.
Right. But here
So,
you'll
if it
understand
is related to
epigenetic,
this
you'll understand.
epigenetics, I know some idea, but I have no base.
But from the basic courses you already started learning, right? We have a couple of lectures which talks about epigenetics, right? I hope you can able
Yes,
to.
sir. Yes, sir. That time I was in a starting trouble. I didn't get anything. Now it is
Oh,
easy.
oh, very good, very good, very good, very good,
Thank you, sir.
very good, very good. Good. You did you understood what was the base flipping which I explained during the classes? The DNA base flipping.
First time I didn't get. Now it is okay.
Okay, so the DNA methylation on the cytosine base
Yes, yes,
introduced.
yes.
Just,
All this. Yes,
it
sir.
is the base is
One of
within
my
the
biomarker is 5MC.
very good, very good.
Of epigenetic biomarker is 5MC. Then H3K4 Me3 and deacetylases,
Those are
histone
the topics
deacetylase. All these are the.
you'll be listening up again. I mean, all the topics will be coming up soon,
Okay, thank you, sir.
right? Good, very good. So, anybody else?
Thank you, sir.
Very good, Gina. Okay.
Good evening,
Thank
sir.
you,
Am I
sir.
audible?
Yes, yes, Salil. Yes.
So my question is actually in two parts. So first, I wanted to know that if there are two types of cancer cells, they have the
You're
same
right.
DNA, but they share different histone modifications. So can we change the malignant states of those cells just by changing the epigenetic landscape? And if theoretically that is possible, how can we like target these specific modifications? Like, can we use CRISPR or some sort of like process to make that happen?
You're right. Right. Yeah. So that's a good point. Yes, the epigenetic state varies from one malignancy to another malignancy. That is known. More importantly, within the single cancer cell populations, there is heterogeneity. Okay, let's assume you have a cancer cell population, like in the breast cancer cell populations. Within the cancer cell itself, there's a lot of variability among the cell populations. There is heterogeneity, what I mean. So the heterogeneity contributed by the differential chromatin modifications among the various cell types. So yes, it is evident, or people have reported, there is a differential epigenetic modification among the malignancies. that is why you have each and every cell behaves differently. Some cell responds better for a therapy, some cell doesn't respond better. All these things we are still understanding stage. But what we know, there is a differential epigenome. Now, second question, is it reversible? It is reversible. How effectively is? Because if it is a global reversible, then you can just put a like drug or silencing the DNA methyltransferases. We can think about it. But what we want is site-specific reversible. Because we don't want to reverse the LD methylations or essential methylations. Only the unwanted methylations or malignant specific methylation need to be reversed. In that case, the targeted epigenome is an idea which is emerging. So what is targeted epigenome? Right after the epigenetic method class, I would have explained the delivery of the epigenetic enzyme to the specific genomic loci using dead Cas9. So basically, you all know about the CRISPR-Cas9 principle, and which is targeting a guide RNA, and then Cas9 will be targeted to the specific loci. But there is a dead Cas9 which no longer cuts the DNA, but still it functions similar to the targeting. Along with the dead Cas9, you fuse the desired enzyme. In this case, if you want to add a methylation mark, fuse the methyltransferases. If you want to add if you want to remove the methylation mark, fuse the TET enzyme, the 1011 translocation enzyme. Right. So likewise, similarly, if you want to modify the chromatin modifications enzyme, so like all these things you can do by using the targeted delivery. This is possible, but this is yet to get translated to the tissue level or animal model level. So maybe some more time we have to understand in detail. Maybe more technology will come. These are the lacunas. Students, next generations, but like the students like you guys should keep in mind. Okay, there is a lot of space here to understand, to develop, and move forward. Okay. Yes, the concept of epigenome editing is already started, and then people are working on it. Cell line level is very successful, but is yet to we reach the tissue level or animal model level.
Right, sir.
Right.
So we could move this towards like the area of personalized healthcare, like
yes, definitely. That is the direction, because even again, within the cancer itself, there is a heterogeneity populations. Right. So where you want to have, because let's assume the skin cell, you have all the healthy skin cell. Among that, bunch of cell will be, cancerous skin cells. So you want to eliminate those cells, or you want to regulate, or bring it to their normalcy status. You want to target only those cell line, right? So that level practically issues and all. Need to move to understand this much better. Why do you want to understand? The question comes. Now we know if you want to add a methylation mark or remove the methylation mark, it will sustain for a few generations. But does it sustain for multiple generations? This is, yet to we understand this. So those are the because what you are trying to do, that one of the differentiated cells, you are delivering an enzymes or epigenetic protein to the target genomic loci, and later you will be monitoring that the purpose is maintained for a multiple generation or not. If it lost after a few generations, the purpose is lost, right? So yes, those are the things actually the actively research groups are looking on it.
Okay, sir. Thank you, sir.
Very good, very good. Good point. Any others?
Sir, I had a question.
Yeah.
Can I ask?
Yeah, please go ahead.
Sure, sir. I have this question, and it's not related to the curriculum itself. It's more of a career-related question. And recently I was looking upon the internet, and I just noticed that having a publication is a must-have in a CV of undergrad student if we wanted to apply for masters in foreign universities, like in Germany or Japan, particularly. I just wanted to know that how to get into it, or how can I approach professors or scholars for this opportunity? And are you aware of such opportunities? It'd be really helpful if you share your thoughts on it.
Yeah, so the first thing is that it's not mandate. Okay, having publications to get into master program. Definitely, it's not a mandate, but it adds or strengthen your CV. Suppose if you have done some undergraduate work, some research work during undergraduate, and that work already you made a manuscript and submitted, or you're a part of some of the ongoing work that has been submitted or published, that will boost your CV. There is no doubt about it. But that's not a mandate, or nobody expect. Okay, you should have a publications to get into master program. But it's expected that yes, you have done some kind of interns or short project work. That always beneficial. But many people, they would like to see that those kind of work or experience is translated to the publication or not. That is why you have this doubt that the publication, or somebody might have informed you, yes, publications will be useful. Yes, it is useful, but it's not a mandate. The second point, this is clear, right, for you, Ashwardhan?
Yes, sir. Yes, sir. It's clear.
Right. Yeah. The second point, suppose if you want to, yes, you strengthen that your CV, by producing your papers, probably you should work in a good lab and then join there and then do your UG projects effectively, even a short project. Then push hard to publish that work along with the professors to get published. When you publish, then automatically, that's the way it goes on actually. But definitely, it's not essential for joining for a master program, for sure.
Thank you very much, sir.
Right. Good. Right. So there is no more questions. Yeah. Sir Pranav, yes, please. Yeah.
Sir, I was just wondering what kind of, especially this is related to the bacterial epigenetics, like E. coli. So what kind of wet lab experiments that we can actually conduct to investigate the inborn epigenetic regulation in bacterial behavior? So recently there was I got to know that bacteria, it regulates its pili formation by just bistable on and off with the DNA methylation approach. But by experimentation, how can we work on to actually get to know it? I know we can sequencing Oxford nanopore or the bisulfate assay, but just some clarity on that.
Right. Yeah. So the first of all, the epigenetic mechanisms in bacteria itself, it's not well characterized. When the methylation marks are present in the bacteria, in the genome, but in this case, you have to understand what is the exact epigenetic mechanisms. It should bring a differential gene expressions, and then that should have an inheritance potential. Only those properties are classified, grouped under the epigenetic phenomena. Whereas in bacterial modifications, somehow it is not well characterized or available or studied methylation mark in case of adenine methylations, which is widely distributed, and its function is largely connected only for the restriction modification functions, basically the acquired immunity function for the bacteria. Of course, the few bacteria started to kind of climb, and a few researchers from the few bacterial studies started to climb. These modification will have an epigenetic functions, particularly cytosine methylation for the bacteria, or maybe RNA methylation in the bacteria. But it's a very early stage to make a very strong climb among these epigenetic community that is epigenetically regulated. But other way around is happening. For example, bacteria replicates within the host cell and it can modulate the host epigenome. That is probably I explained in an introductory class as well. So when bacteria replicates within the host, it modulates the host machinery, and then it uses the host metabolisms to replicate and then moves on. Similar to the virus also does similar way. It doesn't do like bacteria, but also it exploits the host epigenome. Coming to the specific point, what you're telling, the pile regulations, again, it's not exactly epigenetic mechanisms. It is a modifications dependent regulations, and that is why you don't find the conserved epigenetic mechanisms among the bacteria. So whatever the epigenetic mechanisms which I said, which comes under these epigenetic phenomena, are mostly restricted to the eukaryotes, which includes even lower eukaryotes or single cell eukaryotes, amoeba, yeast, and so on. Is it clear, Sir Pranav?
Yeah, yes, sir. Because like bacteria itself has its inborn DAM enzyme, right? The adenine methyltransferase.
Yes, that's all. That DAM
was
enzyme is there. DCM enzyme is there, and these are the enzymes known to methylate adenine, which is not part of the epigenetic functions. But some of the studies claims this enzyme also can methylate on the selected genes, which will have the epigenetic like functions. But again, this is not a very strong kind of scientific or sound scientific knowledge on these epigenetic regulations. Because adenine methylation is a well-studied modification linked with the restriction modifications. Exactly the DAM modification, what you said, DAM DNA adenine modifications.
Yeah, yes, sir. So if not, like if we needed to like synthetically introduce an epigenetic modification, like in case of this DCAS9 and DAM, so will it be possible in bacteria, when mainly in the biomanufacturing area?
I mean, yeah, you see, again, you want to methylate the bacterial DNA and regulate the gene, isn't it? That's what you're trying to say that.
Yeah, yes, sir, definitely, yeah.
Yeah. See, for this, I don't think you need to do this level, okay? Because bacterial gene programming is pretty straightforward, unlike mammalian or higher eukaryotes or eukaryotic gene programming. And bacterial gene programming is a pretty simple. And then mostly people that try to increases the productivity by metabolic upscaling or metabolic engineering and so on. So you don't need to program at genetic level, because the reason the bacteria it's unique in the polycistronic mRNA nature, okay, compared to these mammalian or eukaryote, which is monocistronic, and which is we are not sure how these operons are getting regulated at multiple levels. So it's pretty easy, but since it is polycistronic, and then manipulation at genome level, not necessary at least. You can directly work out metabolic. I don't think you need to go to that level actually. It's a tedious process to improve your biomanufacturing or synthesis via regulating the methylation, because the methylation mediated repression is not a strong mechanism. That is what I'm trying to say that.
Oh yeah, yes, sir.
In case of human or other eukaryotes, the methylation is a very strong repressive modifications. In bacteria, it is not. Yes, in few cases, yes, what do you say, the pile expressions, and then it is linked. But in majority cases, it's not a very strong repressive modifications.
Yeah, yes, sir.
Right.
Yeah. Thank you, sir.
Right. Good. Very good. Happy to know. So, if any other has any specific questions? I mean, if you have any simple, yes, these are things which I did not able to follow it up and so on, and then you can just ask the questions. Okay, so if there is no questions, and then let's close the sessions. Okay, enjoy your the classes, listen, and then we are always welcome to post your comments. I think the NPTEL shared the shared document, right? You can post your comments. And even after every assignments also, I'll get the comments. Any specific things we'll try to address. Otherwise, we can, if needed, NPTEL also can schedule another meeting for interactions. Okay, in next level or the end, you can always have an interaction with me. NPTEL can arrange for that.
Thank you, sir.
Okay.
Thank you, sir.
All the best. All the best. Take care.
Thank you, sir.
Bye. Bye.